Hi dear students of physics. Today I am going to discuss a very important topic known as Van de Graaff generator. सिर्फ 5-7 मिनट ध्यान नाल समझो तो वैन डी ग्राफ जनरेटर बिल्कुल क्लियर हो जू. So let us start. What is Van de Graaff generator? So Van de Graaff generator is a machine or a device that is used to accelerate charged particles like protons, neutrons, even electrons also. So such a device is known as Van de Graaff generator. Now, what is its principle? Its principle is based on two facts. Number one, action of sharp points. Action of sharp points, that is pointed conductor. Now, as sigma is equal to q upon 4 pi r square for a pointed conductor, for a spherical conductor. When r is very small, then sigma becomes very large. It means the surrounding air of the pointed conductor will also acquire the similar charge, and similar charges are repelled. As a result, an electric wind is set up due to the action of sharp points, and this phenomenon is known as corona discharge. So this phenomenon of action of sharp points is known as corona discharge. Second point, when a charge is given to a hollow metallic conductor, when a charge is given to a hollow metallic conductor, it is transferred to the outer surface of the conductor and it is distributed uniformly all over the surface of the conductor. So Van de Graaff working is based on these two facts. Now, what is the construction and working of Van de Graaff generator? So, to understand construction, suppose it consists of a large, hollow, metallic, spherical conductor S placed at certain height with the help of these insulating pillars B1 and B2. Insulating pillars B1 and B2. P1 and P2 are the two pulleys which are frictionless pulleys over which an insulating belt is allowed to pass with the help of a motor M. C1 and C2 are two comb type conductors, pointed conductors. C1 is connected to the positive terminal of the high tension battery, high tension source, electric source, positive terminal C1. C2 is connected to the sphere S, metallic sphere S, with the help of a conducting wire. D is the tube in which charged particles which are to be accelerated are kept, like protons, neutrons or electrons, so are kept in the tube D at this point. And this tube is connected to the target T. The whole apparatus, the whole arrangement is enclosed in a steel chamber C to avoid leakage of charge. And inside this chamber, dry air or methane under high pressure is filled. So this is construction of Van de Graaff generator. Now, how it works? First of all, when this motor M is started, this belt starts running over the pulleys, and when comb C1 is, which is connected to high tension battery, when high tension battery is switched on, C1 acquires positive charge, which is at high potential. Then the air inside the chamber surrounding this COM C1 gets ionized. As a result, large number of positive ions are produced because C1 is at positive charge. Therefore, positive ions will be produced. In other words, COM C1 sprays out positive ions, and these positive ions start going up by riding on the belt in accordance with Bernoulli's principle. What is Bernoulli's principle? Because when belt runs, there is air under high pressure. Air in the surrounding of the belt, velocity increases, pressure decreases. That's why positive ions, instead of going away from the belt, they start riding on the belt and rise. Now, for every positive ion reaching the COM C2, an electron is given out by the metallic sphere S to neutralize that positive ion. As a result, positive charge is produced on the outer surface of the sphere S. So this process continues. Positive ions are reaching at C2. Electrons are releasing from sphere S to neutralize these positive ions. As a result, this outer surface of sphere S starts acquiring positive charge, which increases as machine continue working. So in a sufficient time, this metallic sphere S acquires a sufficient large amount of charge, which produces a very high positive potential of the order of 10 raised to 7 volt potential can be produced by this Van de Graaff generator, which is very, very large. So you can say Van de Graaff generator is also a device that is used to produce a very high static potential, positive charge. So then what happens? These particles, say protons or neutrons, which are positively charged particles, they are repelled with the help of, due to this high positive potential. They gain velocity, they gain kinetic energy, and hence they get accelerated. And these accelerated charged particles with very high kinetic energy strikes the target T. This is how this machine accelerates the charged particles and make them to strike on the target T. So this is the working of this Van de Graaff generator. This steel chamber is also earthed because to avoid leakage of charge. So this is how Van de Graaff generator works. Now what are uses of Van de Graaff generator? It is very simple. The basic principle is it is used to produce very high static positive potential. High static potential voltage of the order of million volts. And this voltage is used, number one, to accelerate charged particles like protons, neutrons, even electrons can also be accelerated with the help of Van de Graaff. Number two, for nuclear research, Van de Graaff is used for X-ray production. This Van de Graaff is used in radiotherapy or cancer therapy to treat cancer patients. And fifth, this Van de Graaff is also used for food preservation. So there are so many applications. The main thing is this Van de Graaff generator produces a very high positive potential, static potential. It may be negative potential also. Electrons can also be accelerated. When we have to accelerate electrons, then C1 is given negative charge. The process is reversed. But to accelerate electrons, there are some limitations, and these are used, some other devices are used to accelerate electrons. So this is how Van de Graaff generator is used to accelerate charged particles, and it has so many applications. So I think you understand each and everything about Venn diagram generator. So keep studying, keep growing, be happy, all the best.